Alright, so let's start with a simple idea. I'll show you how to do it, and then we're going to go outside and do some different things. I'll show you what we're doing. So here's where we started, right? Trig ratio started like this. You remember we've been drawing a whole bunch of these right-angled triangles, yeah? And then we would say, look, there's some angle over here. Who knows what it is? Let's call it theta, right? And then you might get provided with, for instance, you might get given these lengths. This is a right-angled triangle, and you can check those numbers out with Pythagoras if you wanted, okay? So we introduce sine, cos, and tan. Sine theta, cos theta, and tan theta. And we use that mnemonic, right? Are you sick to death of it yet? Sa, ka, toa. Just rolls off the tongue. Sakatoa it is. We use this mnemonic to remember what these ratios were equal to, right? So sine theta is equal to what over what?
Opposite over hypotenuse.
Opposite over hypotenuse. So we can actually write down these numbers, right? Opposite on hypotenuse. So in this case, in this triangle, it'd be 5 over 13. Good. Cos theta is going to be from the mnemonic adjacent on hypotenuse. So that's this one down here, 12 over 13. And your last one, 10, let's get someone else. Let's see. Yes, a pair. Opposite over adjacent. Opposite over adjacent, so the number we're going to write is 5/12. Good. Okay, so remember, these are all ratios. How have we been getting them? We've just been reading them off the measurements that we've got. That's all. Okay? But sometimes you get different measurements. For instance, here I've got all of these lengths and I don't know the angle. But sometimes you know what the angle is. Okay? So here's an example. Let's draw this up.
Do we draw that as well?
Yeah, draw this one up. Let's call this one. Okay. So here is just an example. So I'll write the example. Okay. Now suppose what I'm interested in is what's the hypotenuse in this triangle? It's a right-angled triangle. Usually when we want the hypotenuse, we would say this squared plus this squared equals this squared. We would use Pythagoras, right? Except I don't know what this is, right? I don't know what this other length is, so Pythagoras is kind of not helpful enough here, right? But we can use our trig ratios, right? Remember, I'm trying to find out this, right? So let me give it a name. Let's call it x meters, right? We use pronumerals when we're like, it's a number, but I don't know what it is, okay? And you've got an angle over here. These two sides, we've got hypotenuse, adjacent, opposite. Which two sides are these ones?
Hypotenuse and opposite.
Good, good. This one, the long one, is always the hypotenuse, right? And this one's over the other side, so he's opposite, right? So which ratio tells you opposite over hypotenuse?
Cos.
Look carefully.
Sine.
Opposite and hypotenuse are here together, so it's sine, right? Okay, so here's what I'm going to write down. I'm going to write sine of, instead of theta, I know what the angle is this time. It's sine 30 degrees, okay? By the way, just as a short note, please don't just write sine 30. I know it's very tempting. You have to write it all the time. You're like, oh, do I have to really write the degree sign? The answer is, yes, you should, because there's more than one way to measure degrees. Measure angles. Not just degrees, there are other units, okay? So, sine 30 degrees.
Is there a degrees button on your calculator?
It's nestled under mode. I can show you how to change it later, but you shouldn't, because you should leave your degrees, okay? Now, we said it was opposite on hypotenuse, right? So what should I write in here? Which sides are opposite and which ones are hypotenuse?
Well, x and hypotenuse.
Yeah, it's going to be x and 4, right? Which one's on top?
4.
It's opposite over hypotenuse. So I'm going to write 4 over x. Is that okay? Okay. Now remember, x is what I'm trying to find, okay? But here's where your calculator comes in. Right? This is about using trig ratios with a calculator. This sine 30 degrees, do you remember last lesson we looked at the fact that sine 30 degrees is actually a number, right? And your calculator can tell you what it is. So you find sine in the middle of your calculator on one of those smaller buttons. You just hit sine, and then you put in 30. Sine 30. And it should give you an answer. What does it give you? 0.5 or a half. So I've just evaluated sine 30, as in I found its value, okay, using my calculator, okay? Are you stretching or asking a question? Okay. Now, what did I want to do? I wanted to find x, right? So I'll rearrange this a little bit. Let's see. I'll multiply by x, so he'll go over this side. And then I'll divide by 0.5, so he'll come over this side. Okay? Like so. Now this is a bit awkward. We're mixing fractions and decimals, but that's okay. We just want an answer at the end for this case. Okay. So again, you can reach for your calculator if you struggle to do this. You can say, well, 4 divided by 0.5, and it'll give you an answer. What does it give you? It'll give you 8. Now, just for the sake of it, right? I'm going to show you how to do it by not using a calculator because these are very easy numbers. It's 4 divided by a half, right? Now, when you divide by a fraction, what do? Do you remember how to divide by a fraction? I can turn the division into multiplication provided I turn this upside down, right? So that's going to become a 2, right? So that's 8. That's 8. Okay? So, okay. What do we just establish? We can find other lengths of the triangle if we evaluate trig ratios with a calculator, okay? And that's the way that I would go about it. I guess I should say, yeah, that's 8 meters. From there to there, okay?